Today in geometry, we are jumping back in time to CO5 that we speed ran yesterday, at least for the definitions. Okay, so we'll kind of abbreviate them today. A protractor, but I still don't have a class set for you. But is a tool used to measure angles. We talked about angles measuring in degrees. An acute angle, the measure of an acute angle. Yesterday we wrote it out in words. Today we'll use compound inequalities. If you want to add these to your notes, you can. Otherwise, the words are just fine. But basically, it's an angle measure that is between 0 and 90 degrees, okay? But not including 90 degrees. That's its own special thing. But I think in words, yesterday we said an angle that measures less than 90. An angle can't go negative, and then it is not including 90 degrees. Okay? A right angle is an angle that is exactly equal to 90 degrees. Exactly equal to 90 degrees. Obtuse angle is from 90 to 180, but not including either of them. Right? It's between 90 and 180. Oh, see, last year, those that asked, when would we ever use compound inequalities? Look at us go. Using compound inequalities. We're describing ranges of angle measures. How fantastic. And then a straight angle, which may be new. A straight angle is exactly equal to 180. What would a straight angle look like? What would a straight angle look like? Eli. A line. A straight line. Okay? Right? That is an example of a straight angle. And its measure is 180 degrees. All right? And that's kind of where we left off yesterday. Questions on those definitions, particularly from those who were here? Okay. So, like we talked about with segments and lines and the notation and how to label, we have something similar here with angles. An angle is formed when two segments, rays, or lines intersect. Okay. An angle can be labeled three ways. It can be labeled by number. If I've got a triangle here, I can label this angle, angle 1. And when we talk about the angle is between the segments, rays, or lines, or whatever forms it. Who knows what the corners of an angle is called there? Cole? Called? So vertice would be like, it's vertex is kind of the more common thing. Vertices would be more than one. But vertex is kind of the point of the angle there. And we can label the angle with a number. Notice that there's no degree symbol. That's how you know it's not 2 degrees. It's angle number 2, not 3 degrees, angle number 3. You can also label an angle by letter. Okay? In the triangle here, angle A would refer to this angle right down here, right? Angle B up top there, angle C over on the right. And how you'd write angle A would be a little angle symbol, kind of like a less than sign, but a less than sign goes diagonal, diagonal. Angle symbol goes diagonal, horizontal. Angle A. Over here, we can label angle 1 as being angle 1. Or you can label by sides and by vertex. To where this angle, we could call it angle B, right? Or we could call it angle A, B, C.
Do we need to write this?
Yes. Meaning it starts at point A, goes down through point B, and continues through point C. Okay, angle A, B, C. Now this diagram is not perfect because there aren't actual point markings on it. We'll add them there. Now it's all good. Okay. We could also call it angle CBA, meaning it starts at point C, goes to vertex point B, and then continues out through vertex A. Okay. The important thing is the location of B. Why does B have to be in the middle? Eli? Because it's the vertex, right? The vertex of an angle, when you're labeling it by sides and the vertex must be in the middle. Nathan?
So for the second one, by letter, could it also be 3 then?
Yes. So if you wanted to do angle A here, you could do angle BAC or angle CAB.
And then would that be the same for sides and vertex where it could just be B?
Yes. So where you'd want to use this 3-letter notation, because you're probably wondering, well, why would I ever want to use that if it's 3 letters versus just 1? If you look at the diagram below, and I said, what's the measure of angle P? Well, which angle P? We have P is a vertex here. It could be that angle, could be that one, right? So in this case, rather than saying angle P, APD is a very specific angle. APD goes from point A to vertex P and then out through point D. APD is this angle here. Right? We kind of jump over that PC segment part of it. Okay. DPB is going from point D down through vertex P and out through point B. That would be that angle down here.
Could there just be angle AB?
Angle AB?
Yeah.
No, AB would describe a segment or a line or a ray or something like that.
Are we not going
Okay. If you wanted to label the straight angle down here, if that's what you're asking, it would be angle APB. APB. Nathan's asking about this straight angle. Can you just call it angle AB? No. If you use more than one letter, you have to include the vertex that goes in the middle. Yeah, cool.
Didn't you keep calm and do your homework on that?
No, because we don't have protractors for you, so we're
That's okay.
skipping it. Paisley,
Oh, we're skipping this.
So
we didn't sell enough hedges. What?
it was about protractor.
Oh, yeah.
So are we doing CO6?
Yes, we are going to go on to CO6.
Don't people have
No, I don't have a class on my side.
Yeah, don't people have those?
Some do. Do people have protractors? Does everyone have one?
Yeah, I think so.
Everyone?
No,
I think required.
It wasn't on the.
They're on the list, but not everyone buys what's on the list.
Yeah, no,
They weren't.
They weren't on the list.
They weren't on the list? Oh, there you go.
Last year.
Last year.
No, not last year.
So we're going to jump then to CO6.
Oh.
We need a protractor for this.
No. Huh?
What time do they leave? This looks like it's
Why are we in until 25? No, normal schedule is 12:45.
doing that today.
We're just following normal schedule. We just leave.
3, 2, 1, you are quiet. So, okay, CO6 is finding angle measures by setting up an equation to solve. Whenever you see the phrase set up an equation, you're thinking algebra, because if you set up an equation, you need algebra to solve it. So we are still dipping back into algebra here, but our focus, instead of setting up an equation for segments, like we did in CO2, is now going to be with angles. And in fact, your Khan Academy that was due last week or this week, I don't remember which one, kind of ties into what we're doing here. We have some definitions. What is an angle bisector? An angle bisector. Kaylin.
A ray that divides an angle into two angles that are congruent.
Okay, so an angle bisector is a segment, ray, or line. Remember, initially on CO1, I wrote out the phrase segment, ray, line, but then told you I'd eventually abbreviate it to SRL. Okay? So an angle bisector is a segment, ray, or line that comes from an angle's vertex and divides the angle into two congruent parts. A segment, ray, or line that comes from an angle's vertex and divides the angle into two congruent parts. Finn.
With the SRL, if you flip it to be segment, line, ray, and then forms slur
It does.
instead of swirl.
Yeah.
You could also
Let's go with SRL. I don't know.
you could also do RLS
What?
and then swirls.
into.
No, that's THE.
So just give me a second before you.
I know. By November of your second year with me, hopefully you've got my chicken scratch down. You know that the word the is just one giant letter for me, as is the word and,
Where is the?
as is the
Yeah, what
ER
is the?
letter, the TE letter.
T.
This is the RUEN letter. My alphabet has like
What's
200 different letters in it. But no, that is the word the. A
Wait.
segment ray line that comes from an angle's vertex and divides the angle into two congruent parts. So what does an angle bisector look like? Well, if we have an angle here, okay, an angle bisector comes from the angle's vertex. Try and draw it kind of evenly here. There you go. And divides the angle into two congruent parts. Now, who knows how to label angles congruent? Segments, we talked about that little tick mark, right? What marks angles congruent, right?
There's like 2 lines.
Not lines, we don't use lines. They're arcs, okay? We could label these angles congruent by putting arcs through each of them. That tells you that whatever measure they are the same, okay? They're the same measure. That would be an example of an angle bisector. Linear pair. Linear pair. We should know what the word linear means.
It's a line.
Line, so it has to be the line.
It's a vocabulary.
Okay, yeah.
Paired lines.
Nope, but you're on the right track.
Two or more angles that fall on the same line.
So actually, the fact that a linear pair, it only boils down to two. Okay, a linear pair are two adjacent angles that make a line. Two adjacent angles that make a line. An example, if here is my line here, and I have an angle coming out like this, or I should say a ray coming out like that, angle 1 and angle 2 make a linear pair. The word adjacent, if you haven't heard that one before, it means next to. When we're talking about adjacent angles, is notice that these angles share that side. They share the ray as a side there. And so angles 1 and 2 make a linear pair. What do we know about the sum of a linear pair? What do we know about the sum? The measure of angle 1 plus the measure of angle 2 has to be what, Owen? 180 degrees. If you know that two angles are a linear pair, the other piece of information that you can conclude that they add to be 180 degrees. Andrea, what was your question, comment, concern? Oh, I'm sorry. My bad. Sorry.
Wait, hold up.
Do I have a button that can make you feel it?
Now Avengers button.
No.
No, do the stab button.
No.
Hold up.
I don't.
My doctor.
Questions on linear pair.
You should do wow.
Okay. Vertical angles.
No! Oh, wait,
Vertical angles are
I'm not ready.
two angles opposite each other that share a vertex. Two angles opposite each other that share a vertex. Two angles opposite each other that share a vertex. What this looks like, whenever you have two segments, rays, or lines that intersect, okay, you've got vertical angles, right? Angle 1 and angle 2 are considered vertical angles. They are opposite each other, and they share a vertex, right? This point of intersection here. And does anyone have a guess or knowledge of what the relationship between vertical angles is? Colin.
They're equal.
They are congruent, okay? The relationship, angle 1 is congruent to angle 2.
What's that?
That's the congruency symbol. It's equal sign with a little wavy thing over it.
Those horizontal, they
Right.
So if they're horizontal, they're not congruent with if they're vertical, they are.
So when you say horizontal, what do you mean?
I mean, like the two other angles.
Oh, so the word vertical doesn't mean up and down in this sense. It just means opposite of. Angles 3 and 4, if I were to label 3 and 4 here, 3 and 4 are also vertical angles, and they're also congruent to each other. So vertical angles don't have to go vertically. Okay, the word vertical just means opposite here. But any two angles opposite each other that share a vertex. So you have two pairs of congruent angles there, two pairs of vertical angles, 1 and 2, and 3 and 4. Okay. Angle addition postulate, much like the segment addition postulate, says that the parts of an angle sum to equal the whole angle. The parts of an angle sum to equal the whole angle. Just like with a segment, the parts of the segment added to equal the whole segment length. Same thing with an angle. So, if I have, I'll do it over here. If I have an angle here, and I have this coming out like this, here's point A, vertex B, angle C, I'll call this angle 1 and angle 2. Gosh, my drawings are so good. Did I ever tell you I got a U in art when I was a kid? A U for unsatisfactory.
Is that bad?
Yeah. Yeah, that's bad. Yes, it is.
I thought it was good.
No.
There's a U.
Yeah. No.
Have you ever used somebody a U?
No. So what the angle addition postulate says is that from this angle, the relationship I can write is the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Okay? The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Basically, the two parts that I divided this angle into, 1 and 2, add equal the whole thing. Okay? So if angle 1 was, 20, and angle 2 was 70, you could know that the whole thing, ABC, would be equal to 90. Okay? What's that? Yes, you could also label it angle CBA. That is. Okay? Not just CA. No, you need the vertex in there. Yes?
You can get BAC
You cannot do BAC because the vertex needs to be in the middle. Vertex must be in the middle. Okay? Questions on any of these notes?
No.
All right. No, not quite yet, Paul. Don't jump the gun here. Marking angles congruent. We already talked about this. Notice the use of the arcs here. And also, again, I want to establish the difference between congruency and equality. Congruence is simply the same. Equality is to have the same value. Okay? Same value. So the difference is when you're marking two angles as the same, it's angle A is congruent to angle B. That means the measure of angle A is equal to the measure of angle B. That little lowercase m means measure. And notice the use of the equal sign because we're talking about the value of the angle, right? It's measure. You'll see that difference pop up again when we talk about proofs, but there's a difference between congruency and measure. Here's the algebra piece. I give you a diagram. You need to identify what the relationship is, right? What do I have here? What's going on? So you know what equation to set up. Okay? It says, find the requested angle measure. Check your answer by verifying that the relationships work. If I'm asking for the measure of angle ABC, well, ABC is right here from point A down to B and over to C. CBE goes from point C down to B and over to E. So I'm looking for this angle here, and I'm looking for this angle here. And here's where your understanding of the relationships matters. What equation can you set up here based on what you're told? Andrea?
vertical angles are, so you could use 4x minus 14 equals 2x plus.
Okay, so you've got to look at this and you've got to say, hey, I've got a pair of vertical angles here. How do I know they're vertical angles? Well, these two angles, 2x plus 7 and 4x minus 14, share a vertex, vertex B, and they're opposite each other. Okay? And because you recognize them as being vertical angles, that leads you into what the relationship is. What is the relationship between vertical angles? They're equal. They're congruent, right? So the equation we can set up is 2x plus 7 equals 4x minus 14.
Why did that?
Why is it that? Because those are the measures of the angles. And I know that because they are vertical, they are congruent.
I didn't see like mine. Oh, so they.
Since we're talking about their values here, it will be equal.
So like, what do we do now?
We are setting up an equation to solve. An equation is all about the value of the variable, so we use the equal sign. So now we've got a classic variables on both sides equation. I'm going to move my 2x's over to the right. I'm going to add 14 to both sides to move everything where I need it to be, and I get 21 equals 2x. And what's our value for x? 10.5, right? Divide both sides by 2, and we get 10.5 equals x. Now that's not my answer, right? I'm looking for what is the value of ABC.
28.
ABC is 2x plus 7, but I now know that x is 10.5. So 2 times 10.5 plus 7, 28 degrees. Now, do I have to plug in 10.5 into 4x minus 14, or how do I get that CBE? There's no measure listed there.
What do you mean?
Well, the other angle I'm looking for is CBE, the one I have there in green. There's no equation, there's no value listed. Izzy, how do I get it? Yes, I've got a linear pair as well. Right here,
Oh yeah, it's
ABE right here is a straight line, right?
yeah.
Okay? Which means if this part up here is 28,
That's 180.
this has got to sum to 180,
Yeah.
which makes it 152 degrees, because 152 plus 28 equals 180. You see how geometry is all about relationships. Okay? I don't see how you can't. Because if you don't recognize these as being vertical angles, you're in trouble. What the relationship is, right? You can even tell me, yeah, they're vertical angles, but if you don't know what that means, how are you going to get this equation? You have to know what their relationship is. Okay? Paul.
Yeah, because I'm calling one of our questions have like the angle and then give us a hint that ABC or is a straight angle and then tell us and then subtract.
Sure. Yep. Exactly. It's all about those ways. Sam. Shh. Colin.
Couldn't you also say that the circle's 360? And
Yes.
You subtract 56?
The other beautiful part about geometry is that unlike algebra, where it's like, first I move my terms over, then I do this, then I do that, there are a lot of different ways you can get to what you want. And we're not going to go over all of them. Okay? There are lots of different ways you can get what you want. These three, then we got to go on to the next one. Yes.
Can you show
Nathan.
me what a congruent angle would be? I don't get, or two congruent angles. I don't know. I don't get it.
Congruent angles would be like what we have here. Okay.
Wouldn't
These.
that also be equal?
Yes, they're equal because their values are the same. Right? We would mark them congruent using the arcs. We would use their equal values to set up the equation. Okay? Really, I think I overplayed the difference between congruency and equality. It really doesn't come into play until we start doing proofs. Okay? So don't get hung up on it now. Just recognize that vertical angles are congruent. They are equal, and we can use that relationship to solve for x. Okay? Andrea, we will get to that next. Yes,
Can you
Colin.
give us an example of something that is congruent but not equal?
No, not right now.
Please.
Just because we got 3 minutes left and I want to get your homework. The next one, you're looking for angle POR. POR is this angle here. Right? What I have there in green. And ROQ, from point R down to O and over to Q is this little piece here, this angle on the right here. What equation can I set up that's going to allow us to solve for x and be able to plug that in to get the measures that we want? Cormac.
5x plus 4 plus x minus 2 plus 3x plus 7 equals 1.
Wait, hold up. What is it? X?
I'm so confused.
Wait.
Oh, yeah.
Okay. What Cormac is noticing here is that POQ is a straight line, which means that POQ is a straight angle, which means that the measure of POQ is 180 degrees. So then the question becomes, what makes up POQ? Well, POQ is the sum of 5x plus 4, that's part of it, plus x minus 2, that's another part of it, plus 3x plus 7, that's the third part of it. These three angles together add to make the whole straight angle POQ.
Got it.
So the equation I set up here, 5x plus 4, here's angle POS, right? Here's angle SOR. Here's angle ROQ. Those three angles together, their expressions add to be 180.
R-O-Q?
Okay? Good. Now, do those three angles make a linear pair?
Yes.
No.
No, never.
Linear pair is only two angles.
I-
But they do add to be 180,
50-50.
which is why we can set this equation up.
What's 171 divided by 2?
You can do it. What's 180 divided by 9?
It's
Too much. 20.
20, and 171 is 1/9 fewer.
What?
Oh, so it's 19.
wait.
There you go.
Your homework for tomorrow. You can do it. Finish this question. We've got the equation set up. You just got to solve it. And then from your textbook, it does work. If you combine like terms correctly, it definitely does work. Let's have you do.
One question. We have like 3 questions.
Oh, it's 1.
On page 39, I'd like you to do 17 through 27. 17 through 27, and then 31 through 33.
That's a bit long.
17 through 27, 31 through 33.
We have to finish.
Hold on, just so I don't get accused of not saying this tomorrow, your work must be shown. SW means show your work. Your work must be shown. No
We have to
shown
do
work
the
is no.
second
Yes, you gotta finish.
I'm not gonna show my work, but I have to.
All right, folks, that's how you math